Suppose we want to add. To have square root of A plus square root of B, you cannot write it as square root of A plus B. They're not the same. You can verify this in the calculator, or even regular simple numbers. Let's take square root of 4 and square root of 9. Both of them are perfect squares. Square root of 4 is 2. Square root of 9 is 3. 3 plus 2 is 5. Is that equal to square root of A plus B? 4 plus 9? No. Because square root of 4 plus 9 is square root of 13. Square root of 13 is not equal to 5. Square root of 25 is. So if you have roots, you can't simply add them and combine them and put it away, put it under one root. Same rule applies to subtraction. Remember, earlier I mentioned that subtraction is the same as addition, but we just view it as a number added to its additive index. So naturally, whatever holds true subtraction also. Multiplication. If you have square root of A divided by, oops, brain's going faster than I wanted to. Square root of A times square root of B. In this case, I can put those two together and write it as square root of A times B. Likewise, division, square root of A over square root of B, I can combine them and write it as square root of A over B. So the last property here, square root of A, if you square it, the root and the square will get cancelled. Mind you, I can write another property. Square root of A raised 0 is 1. Any number raised to the power of 0 is 1. Includes square root of a number, because square root of a number is a number. We want to add root 2 and 3 times root 2. The answer is straightforward. It's 4 root 2. But people oftentimes have difficulties grasping that. So think of that as an apple. So you have 1 apple plus 3 apples. In total, you would have 4 apples. But I called an apple to be a root, particularly square root of 2. So the answer is 4 root 2. So let's simplify. Root 5 plus 3 root 25 plus 4 root 75. We want to simplify in the sense we're just going to pull common terms out. Now, root 5, there is nothing I can do about it, so I'll just have root 5 plus 3. Root 25 is simply 5. Square root of 25 is 5. 4, square root of 75. I can express that in terms of another square root. So 25 is simply 25 times 3. Using one of the properties, if I can multiply individual roots and combine them like the way I did in property 3, I can do the reverse also. In other words, I can split the root as long as I am multiplying or dividing. So square root of 5 plus 4 square root of 25 times square root of 3. Square root of 5 plus 15 plus 4 square root of 25 is 5 times square root of 3. Square root of 5 plus 15, 4 times 5, 20. Square root of 3. That is the best we can do because we can't combine it any further in terms of simplification. We want to simplify 3 square root of 18 plus 5 square root of 50. So the first step is to split the number inside the root in terms of perfect squares. That is the key. We have to write it in terms of perfect squares. So the perfect square, that is in 18, is 9. 9 times 2. The perfect is 25, so 25 times 2. Since I have multiplication inside the root, I can split the root. 3 times square root of 9 times square root of 2, 5 times square root of 25 times square is 3. Square root of 25 is 5. And the root 2, I'm going to leave it as is. 3 times 3, 9, root 2. 5 times 5, 25, root 2. Add them together, 34, root 2. So we want to write the numbers inside the root in terms of perfect squares, if at all possible. The perfect square in 63 is 9. 7. The perfect square in 28 is 4 times 7. I can split the root by product. So square root of 9 times square root of 7 minus square root of 4 times square root of 7. 9 is a perfect square. Square root of 9 is 3. Square root of 7. Square root of 4 is 2. Square root of 7. 3 square root of 7 minus 2 square root of 7 is 1 square root of 7, which is 1 times square root of 7. And that is square root of 7. And that's the answer.